Hi everybody, in this video we're going to talk about converting units. We're going to answer two questions, and each question we're going to answer in two different ways. Once using the multiplication strategy, and then again using the proportion strategy. So let's get started. The key of the map of Mathtopia, here's Mathtopia over here, a utopia of math, says that every 2 inches on the map corresponds to a distance of 300 meters in real life. So every 2 inches that we see drawn on the map, 1, 2, let's say, corresponds to 300 meters in real life. If the distance from Constant Castle to Variable Village is 6 inches on the map, how far would it be in real life? So let's just sketch what's going on here. Let's say this is Constant Castle over here. And let's say Variable Village, this whole area is Variable Village, let's say the distance from here to the center of Variable Village is 6 inches on the map. Okay, so something like that, from here to here, or from here to here, either way, is 1, 2, 3, 4, 5, 6 inches, but obviously it's not 6 inches from those two places in real life. Every 2 inches corresponds to 300 meters in real life. So if we have 6 inches over here, 1, 2, 3, 4, 5, 6, how far apart would they be in real life? Well, you might be able to figure out the answer by looking over here. Actually, you know what? Let's do it 3 ways, actually. We could answer this question by thinking about it this way. Every 2 inches here, 1, 2, is 300 meters in real life. And then another 1, 2, that's another 300 meters. Another 1, 2, that's another 300 meters. Okay, and then if we add all these 300s up, 300 plus 300 plus 300, that would give us 900. So it would be 900 meters in real life. So that is another way that we could answer the problem if the numbers are easy enough. But I also want to talk about these two strategies over here. So let's do that. To do the multiplication strategy, here's how you would do it. Start off by writing the number that you're given. Okay, so that was 6 inches. So I'm going to write the number that I'm given, and I'm also going to write the units for that number. So that was 6 inches, not 6 meters. So I'll write IN next to the 6. That means 6 inches. Now I'm going to write a multiplication symbol, and then I'm going to leave a little bit of space here for now, and I'll write an equal sign over here. You'll see why I'm doing this in a minute. And then over here, I'm going to put a little question mark because I want to know how far they are in real life, but I'm also going to put the units that I'm looking for. So if the question is asking me how far apart they are in real life, well, in my real life distances are measured in meters, so I'm going to put an M over here to indicate that I want my final answer to be in meters, not in inches. Okay? And now the way that we do it is we're going to write a fraction over here. And this is why we started out by doing it this way, by writing the inches over here and the meters over here, because I have to know in my fraction, do I want to put the inches in the numerator and the meters in the denominator, or do I want to put the meters in the numerator and the inches in the denominator? And the way that we answer that question is by thinking of it this way. Units cancel out in the same way that numbers in fractions that we're multiplying cancel out. Okay, so for example, let me just pick completely different numbers here. If I had something like 20 times 3/20, then an easy way for me to figure that out is just to say that these 20s are just going to cancel, and the answer to that would just be 3. Okay, 20 times 3/20 is 3. If you don't believe me, then what you could do is you could put this over 1, and then you could say, well, 20 times 3 is 60, 1 times 20 is 20, and 60 divided by 20 is 3. Okay, so that's the same thing that I just told you a few seconds ago. So the fast way for me to figure that out was to just say, okay, this 20 and this 20 are going to cancel, and then I just have this 3 left over. Now, why do I bring that up? It's because units cancel in the same way that fractions do. So if I put the inches over here and the meters over here, then this and this are not going to cancel. They have to be the same in order to cancel out, just like these 20s are the same over here. But if, on the other hand, I put the meters on top and I put the inches on the bottom, then these inches are going to cancel out, and I'm left with just meters, which is exactly the unit that I was looking to have in the end. I want my answer to be in terms of meters. Okay, so that little analysis there tells me that I should be putting meters in the numerator and inches in the denominator, and therefore these cancel out, and I'm left with just meters, which is what I wanted. Now, why did I bother even going through all of that? It's because I want to know if I should be putting this 2 in the numerator and the 300, right, in the denominator, or should I be putting the 300 in the numerator and the 2 in the denominator? In order for me to answer that, I'm just going to take a look at the units that I have over here. So I put meters in the numerator and inches in the denominator. Then going back to the key over here, I have 300 is the number that goes along with meters. So I'll put a 300 over here. And 2 is the number that goes along with inches, so I'll put a 2 over here, okay? And now I can go ahead and solve the problem. And I'm just going to do it down here, actually. So we are doing 6 times 300 over 2. So those are the numbers that we're multiplying, 6 and 300 over 2. Okay, so there are a couple of different ways that we could do this, but one way is just to put this over 1, and then do 6 times 300 is 1,800, 1 times 2 is 2, and then 1,800 divided by 2 is 900. So that's the same thing that we said over here. Okay, so the final answer is going to be 900 meters. So notice that most of that was just doing that unit analysis. So if I'm starting with inches, and I know that I want to end up with meters, then I should be multiplying by meters over inches. And then that tells me if the 300 should go in the numerator or the denominator, and if the 2 should go in the numerator or the denominator. Once I know what these units are in this fraction, then I just take the numbers from the key and plug them into the right spot. And then I can just go ahead and multiply the numbers, which I did down here. Okay, so that's the multiplication strategy. The trickiest part is doing that unit analysis. Now let's move on to the proportion strategy, which I think is probably a little bit easier. So for the proportion strategy, we're just going to take the numbers in the key and turn them into, just write them in fraction form. And make sure that you write them along with the units. That's very important. So we have 2 inches, okay, that's from the key. I'll put that over 300 meters. Don't forget to write these units, inches and meters. Then I'll put an equal sign, and then another fraction bar. And now I'm going to go back to the question. So I was told that it's 6 inches on the map. So think for a second, should I put that 6 in the numerator or the denominator? Well, since I put inches in the numerator over here, I have to be consistent on the other side and put inches in the numerator over here also. Okay, so since this is 6 inches, that should go in the numerator because we had inches over here in the numerator. And then in the denominator, we're going to be putting x. And we could also put meters, right? So x meters, how many meters? how many meters would go along with 6 inches if 300 meters go along with 2 inches? That's the question that we're asking by setting up this proportion. So there are a few different ways of solving this, but one way, which always works, is to cross multiply. So 2 times x, forget about the units for a second. That was, the whole purpose of putting the units in was just so we knew if we should put the 6 over here or down here, and if we should put the x over here or up here. So we had to look at the units to decide where things should go. But now that we have everything in the right place, now I'm not going to pay so much attention to the units, and let's just look at the numbers. So 2 times x is 2x, and then let's write an equals sign over here. 300 times 6 is 1,800. And then to solve this equation for x, we're just going to divide both sides by 2 to cancel this 2 over here. And we would get x equals 900. That's the same answer that we got over here and over here when we added up all of those. Okay, so that's the, oh, I forgot to circle these, right? That was 300 times 6 gave us the 1,800. Okay, so that's the proportion strategy. I just want to point out a very common mistake back over here in the multiplication strategy. I see it so often, which is students, when they get to this part over here, then they would try to do this butterfly thing, the cross multiplication that I did in the proportion strategy. They would try to do 6 times 2 and 300 times 1, and that is incorrect. Notice that we only do that when we have an equal sign in between those two fractions. But if it's just a multiplication symbol, okay, if we're just multiplying these numbers, then we don't do the butterfly thing, okay? We just multiply the numerators and we multiply the denominators. So don't do the cross multiplication if you see a multiplication symbol here. Don't do that for the multiplication strategy. I know it's a little bit confusing, but you do the cross multiplication for the proportion strategy when you have that equal sign in between the two fractions. All right, so let's go ahead and do one more example. Okay, we'll use the same premise over here. We're still looking at Maptopia. The key of the map of Maptopia says that every 2 inches on the map corresponds to a distance of 300 meters in real life. So that's pretty familiar to us. It was the same as in the last problem. If the distance from Rhombus River, I just got paranoid for a second. I thought maybe I wasn't recording and I was just talking to myself for the last 5 minutes or so. But no, I'm recording, so good. If the distance from Rhombus River to Mount Multiplier is 450 meters in real life, how many inches apart would they be on the map? Okay, so let's just do another problem to practice using these strategies a little bit more. So if I want to do the multiplication strategy, then I would begin by taking the number that I see from the problem, which is 450 meters, and let's write that 450 m for meters, okay? It's very important that you write it along with the units, okay? We're going to write the multiplication symbol, then we're going to leave a little bit of space, write an equal sign, and then question mark. And what units do we want our answer to be in? We want our answer to be in inches, because we're trying to figure out how many inches apart these two places would be on the map. Okay, so we want our answer to be in terms of inches. Now we can go ahead and write a fraction bar in here, and then we can ask ourselves, where should we put the units here in our fraction? Should the inches be in the numerator or the denominator? Should the meters be in the numerator or in the denominator? Well, remember, we want to cancel out this meters over here, and we want to have inches left over. Okay, so we want meters to be in the denominator, because then this meters and this meters just cancels out, okay? And so we should be putting inches in the numerator. Okay, again, units cancel out in the same way that fractions do. So if I have meters here and meters here, then they cancel out. And the only thing that I'm left with is just inches, which is what I wanted because I want my answer to be in terms of inches. Now, the reason that we did that little analysis there was to decide if where the 2 and the 300 should go. So now that we did that analysis and we know that the meters should cancel out like this, now we know that the 2 should go in the numerator because that should go next to the inches. Okay, 2 inches over there. And we know that the 300 should go in the denominator because the 300 should be going next to meters, right? So 300 meters there. And now that we know where everything is, then we can just go ahead and multiply these. So 450 times 2 over 300. Okay, again, don't start cross multiplying over here, right? Maybe you could put a 1 over here, but don't start cross multiplying. That's for the proportion strategy. That's if we had an equal sign between these two fractions, then we would cross multiply and solve for x. We don't even have an x here, okay? Not the variable x. What we do have is this, well, that's a multiplication symbol. It's not like the variable that we're looking for. Okay, so we should not be cross multiplying here. We can, though, we can put a 1 under the 450, and then we're just going to multiply the numerators and multiply the denominators. So 450 times 2 is 900. And, oh yeah, and I got confused for a second, but never mind. 1 times 300 is 300. And then 900 divided by 300 is 3. Okay, so that's what our answer is. So we just figured out that if these two places, Rhombus River and Mount Multiplier, let's say this is Rhombus River over here. Let's say, let me switch to, I don't know, switch to pink. Let's say that's Rhombus River and this is Mount Multiplier over here. Then these two things would be 1, 2, 3 inches apart on the map if they were 450 meters apart in real life. Okay, now let's go ahead and use the proportion strategy. So for the proportion strategy, we're just going to start off by writing the information in the key as a fraction. So 2 inches over 300 meters. You could also put 300 meters in the numerator and 2 inches in the denominator. That actually does not matter as long as you're consistent on the other side. So however you put the inches and the meters on the left side, then you have to do it the same way on the right side. So I decided to put inches in the numerator and meters in the denominator, so I have to do the same thing on the right side over here. Now I'm going to go back to my question, and the question told me that it was 450 meters in real life. So I need to put that 450 by the m over here, because that was 450 meters. And I'll put an x over here. X is what I'm looking for. Now, here I will cross multiply. So 2 times 900, 2 times 450, I just gave away the answer there, is 900. Then let's put another equal sign. 300 times x is 300x. And then to get the x by itself, we'll just get rid of that, we'll divide by 300, but we have to do the same thing on the other side as well. So we'll divide both sides by 300. It cancels over here, and we have x equals 900 divided by 300 is 3. So same answer that we got using the multiplication strategy. Okay? All right. So that is it, and have a great day.